Good evening. Good evening, ladies and gentlemen. Hello, welcome. Good evening. Thanks, David. Hi, I'm Elizabeth Greenway. I am the Executive Director of Griffith Observatory Foundation, and it is my pleasure to introduce tonight's program, From Greenwich to Griffith. Griffith Observatory is celebrating its 90th anniversary. Happy birthday! As part of this very special occasion, we are honored to welcome a delegation of distinguished guests from the Royal Museums Greenwich as they celebrate the Royal Observatory's 350th anniversary this year. I'll say. So this week marked my 6-month anniversary as the Foundation's new ED. Thank you. While this milestone might seem like a pebble compared to the pillar of Griffith Observatory or the monolith of Greenwich, I am so proud of all that the Foundation's board and staff have accomplished this year to help celebrate 9 decades of observation, understanding, and inspiration for people across Los Angeles and around the world. The mission of Griffith Observatory Foundation is to support and promote the observatory as a home for science literacy, education, and public astronomy. Contributions from donors and members underwrite the observatory's signature school program, serving more than 50,000 students here at the observatory and online. Together, we also fund essential staff, exhibit updates, global astronomical broadcasts, and technology projects like the observatory's new free Wi-Fi. Yeah, that's good. You can check the score of the Dodger game after the lecture. Just wait till after. And through events and programs like this one, we also bring people together like no other place on the planet. Do we have any Foundation members here with us tonight? Can I see a show of hands? Thank you very much. Thank you and welcome. Thank you so much for your support. If you are not yet a member, join us. Your contributions make Griffith Observatory free and accessible to everyone and help to ensure this beacon of learning, beauty, and inspiration will continue to shine brightly to the next milestone and beyond. We gratefully acknowledge the British Consulate General Los Angeles and His Majesty's Consul General Paul J.G. Rennie, OBE, for their support and collaboration in bringing tonight's program to fruition. I would also like to take a moment to thank our 90th anniversary sponsor, Amazon, for its generous support of this landmark year at Griffith Observatory. And now, without further ado, it is my pleasure to introduce the Director of Griffith Observatory, Dr. E.C. Krupp. Ed.
Thank you very much. Thank you, Elizabeth. I've had the good fun of speaking now 2 days in a row with Paddy Rodgers, and frankly, I would just as soon go back to the other room and continue the conversation. It was that good, but you get to have a bit more of it and hear some remarkable stories about astronomy and, of course, the Royal Greenwich Observatory. I just want to state the obvious. Griffith Observatory and Griffith Observatory Foundation share with Royal Museums Greenwich a commitment to public astronomy. And, of course, the Royal Museums Greenwich include the world-famous and historically profound Royal Observatory Greenwich, the place where the day begins every day on the prime meridian, fundamental reference in our long pageant of engagement with the sky. And more people, probably most people, know the Royal Observatory Greenwich is important. Novelist Joseph Conrad made it a victim of a terrorist bombing in The Secret Agent in 1907. In 1996, it was a crucial plot element in the Where in the World is Carmen Sandiego comic book. Certainly the UK Royal Mail knows it's important. In 1984, it issued 4 postage stamps to commemorate the centennial of the Greenwich Meridian. Now, just now, in 2025, it has just released 6 stamps and a philatelic souvenir sheet in honor of the observatory's 350th year. Over the decades, the Royal Observatory Greenwich has made numerous appearances in Griffith Observatory's monthly magazine. You don't have to believe me. I can wave just a few of them at you here. So it regularly shows up in Los Angeles. Royal Observatory Greenwich and Griffith Observatory are both celebrating, as you heard, significant anniversaries this year. Griffith Observatory's 90th year is, however, just 1/4 the impressive longevity of Greenwich. But both milestones underscore something that guides both of our institutions, and that is heritage. Both institutions also occupy high ground in charming settings with elegant architecture. You can't beat that. But Griffith Observatory also has a meridian in the Gottlieb Transit Corridor. It's not the Greenwich Meridian, it's the Griffith Meridian. It's not the prime meridian, but it's pretty good. Now, any astronomer with any sense of astronomical heritage makes a pilgrimage to Greenwich, and I've done so several times. The first in 1973. I then went to Britain to see and document prehistoric monuments, alleged, like Stonehenge, to incorporate astronomical alignments. And I brought back wraparound photographic landscapes of Stonehenge, for example, to be transformed into 360-degree panoramas in the planetarium, projected in there. I also made a point on that trip, of the very first archaeoastronomical trip, to visit Greenwich and do the same thing there. Well, tonight, Paddy Rodgers, Director, Chief Executive Officer of the Royal Museums Greenwich, will highlight the elemental and world-changing contributions of Greenwich in astronomy and timekeeping and navigation and their impact on culture and civilization. And he has held this post since 2019. His law degree was conferred by University College London, and he has a long and storied career in seafaring and the maritime industry. He understands the value, then, of knowing where you are when you are in the middle of the ocean. But we are honored to have him here, anchored tonight in the cosmic harbor of Griffith Observatory.
Thank you very much, Ed. Good. Well, first of all, I must say that it's lovely to see you all, and I'm very honoured to be here, partly because, of course, I get the great satisfaction of representing the Royal Observatory to you, but also in front of an audience in such a wonderful location and such a significant observatory as the Griffiths. And I'm not going to hold you up, but I'm going to tell you now a little bit about Greenwich, but I really want to set it in a context that connects the stars and celestial observation with the human story, the significance not just to us economically, socially and politically, but also to us as individuals. So I hope you will bear with me as I romp through 350 years, and we'll see how we go. And if and you can just shout faster if it's getting boring, or slow down, and then it'll be a bit like one of those clocks that didn't really work. But let me just. We might be off to a sticky start here. Let me just check. Am I going to do it? There we go. Good. Right, here we go. So that was the starter slide. Is everything all right there, Matt? Do you think?
Are we good?
I need to point it at that, don't I? You see, that's like a never mind. We won't go there. I very cheekily always tell people that I'm from the most beautiful location, not just in London, but possibly in the world. And I came up here this evening. I thought maybe I ought to wind my neck in a bit, because it's quite attractive up here too. But let me just show you this, because don't you agree that's a fantastic site? So this, of course, is the... oh, that's the one. So this is... this was the old docks. This used to be the Dockland area. That's quite important for this story, because all along this river and in those docks, in the 19th century, there would have been ships waiting to load and discharge cargo. But this was a very, very famous area for a long time. Now, Henry V gave this area to his brother, the Duke of Gloucester, and it was turned into a hunting ground. And so the royals used to come down here. I mean, they didn't really hunt. The deer were all there. They knew where they were. They just went and killed them. It's not hunting like looking for them. They were on their land. They knew where they were, right? So this was a hunting ground, and it's very famous because this hunting lodge became a little bit of a palace. And then as the Palace of Placentia, it became a place where in the Tudor era, the queens were sent for the third trimester of their pregnancies, so that they could be away from the noise and away from the crowds. And as a result of that, Henry VIII and Elizabeth I were both born at Greenwich. So you begin to get a feeling for why we're Royal Observatory Greenwich. So this is very connected with the royal family. And this hunting continued to the start of the Stuarts. And the Stuarts are really important for Greenwich because the period that all of these buildings that you can see were built were in the Stuart dynasty, starting in 1603 with James I through to 1715 with Queen Anne. And James came down here with his wife Anne of Denmark, and they used to go shooting, and she shot his favourite dog. And he berated her publicly. And then the next day he was told that it was the language he had used, the way that he had done it, was absolutely unacceptable, and he had to give a mollifying present. And the mollifying present that she demanded was this. Built in 1616, it's the Queen's House, the first neoclassical building in Britain. And the rest of it was Tudor red brick rubbish, but this was an absolute jewel in the crown. And it was turned into a house of beauty and delight. It was used to welcome ambassadors, and we use it as an art gallery now in the museum. Beautiful building. She didn't see it completed. Charles I, who was the son of James I, he and his French wife, Henrietta Maria, finished it, and they were art lovers. The ceiling was painted by the Gentilesches. The great works were done in this building. And the royal family always loved it. But things went wrong. And I'll take you to the things that went wrong, and we might come back, but just remember this building, absolutely beautiful, because the next bit, the other bit that I just want to make sure you keep in your minds is that when eventually the next stage of building is done, this area here is built by Christopher Wren. So Inigo Jones and Christopher Wren, these are really the creme de la creme of artistic architecture. The architecture we live in, architecture is the art that we live in. You can see here eventually where we end up. This is the observatory when it gets built, and here's the Queen's House. And you'll see the palace is not yet built. Charles I liked to spend money, but Parliament had to pay for it. So they had a kind of, I'm struggling a bit with that, they had a kind of government shutdown. None of them, I know you'll struggle to find the relevance to a lot of the stories I tell, but as a result of that, we had a civil war. And as a result of the civil war, Charles I had his head cut off by the parliamentary forces led by this guy, Oliver Cromwell. Famous from the Elvis Costello song, Oliver's Army, but it was a professionalised army, and it kicked out the royal family, because the other thing that was really popular at the time were demonstrations, military demonstrations called No Kings. So Charles, rather like a gap year student, was exiled, and he had to go around Europe, and as he went around Europe, he had to sleep on relatives' floors and on their sofas and all the rest of it, and he spent a lot of time in Versailles, and he just kept thinking, one day. And of course, the day came. Oliver became more and more like a king with less and less style. He outlawed, the Puritans under his control outlawed Christmas. They stopped dancing around the maypole. The theatres were closed. Life was pretty grim. So eventually people got fed up. Oliver Cromwell died. His son took over, was unsuccessful, and then they wrote a petition and asked Charles to come. And Charles came down the river with his brother James II. And I tell you, the Stuarts, the one thing you can't say about them was that they were tight with money. They knew how kings should live. and they were really looking forward to ripping it up in a big style. So I always had this image of them coming down the Thames in their boat, James and his newly crowned brother, Charles. There's a soundtrack to that, and I think it's got to be Thin Lizzy, the boys are back in town. So they get there, and it's time to live it up. Well, one of the things that Charles is very famous for is he had a lot of mistresses. And one of them, Louise de Carroy, who may well have been in the pay of the French government, told him that the French had discovered the exact calculation of longitude. And he didn't believe it, he wasn't sure of it, but he knew that we had to beat them. So he built an observatory on top of what would become the Versailles of London. Now you think about those white buildings I showed you earlier on. He really wanted it to look like Versailles. He got the gardener from Versailles to reshape Greenwich Park. And in Versailles they had an observatory, so he wanted to have an observatory, so he built one in Greenwich, and he got Christopher Wren to do it. But this was the reason. We have appointed our trusty and well-beloved John Flamsteed, Master of Arts, our astronomical observator, forthwith to apply himself with the most exact care and diligence to the rectifying of the tables of the motions of the heavens and the palaces of the fixed stars and the places of the fixed stars, so as to find out the so much desired longitude of places for the perfecting of the art of navigation. And why was navigation important in 1675 when it seems to have been not so important 100 years earlier? And basically, two reasons that I can think of, and which I think are substantially correct. One is, of course, the discovery of the Americas. And then all of a sudden, trade changed. Most trade for Britain had been with Europe, and basically you can't miss Europe. Whether you're coming out of Europe, you're going to hit Britain, and if you're coming from Britain, you're going to hit Europe. So, and if you think about the Portuguese going to the Indies and going out to the Far East, they basically coast hug. They come down Africa and they go out to the east, but it's slow work. You're not going in the most direct route, and it's not effective. So if time's important to you, then you don't want to do it this way. But of course, when you come to the Americas, you've no choice. You've got to go out into deep ocean. You don't want to do it the way the Vikings did, island hopping, going to Iceland, Greenland, and then coming down from Newfoundland, because you want to get to the Caribbean or to South America. So it was quite clear that you needed to move on the oceans. And the second thing that was important is that Dutch lens grinders had created big enough lenses to make telescopes. And that had been perfected by Galileo earlier in the century, and he'd taken a piece of equipment that was used for seafaring to look for obstacles at sea, or for people in ports to see the ships that would come in and which cargoes they would bring. Galileo had taken it and turned it on the stars. And this was a new science and very dramatic. Let me tell you, telescopes save lives, not just because they make sailing safer, but they also make life safer for scientists. Giordano Bruno was a mathematician who had calculated and could prove through complex mathematics that we lived in a heliocentric solar system. And he was burnt at the stake. Nobody bothered to read the maths. They just said he was a heretic and burnt him. Galileo, on the other hand, took them to his telescope, pointed it at Jupiter and its moons, and said, "Explain this to me then." So he got away with it. Well, life imprisonment with a constant threat of torture. Something like getting away with it. But everything has changed, because ultimately we begin to get a proper sense of the world. Now, the reason I've chosen this is because all that's marked on it that I wanted to highlight was just the critical lines of latitude. The important thing about latitude is that it's real. So unlike the meridians, latitude lines are real things. The equator is a real thing. A pigeon knows where the equator is. Your dog will know where the Arctic Circle is. Not when it's at home, but if it got there, it would understand it. The Arctic Circle, the sun disappears for 3 months of the year, and for another 3 months of the year it doesn't go away at all. This is a physical fact of life. So if you think about understanding where you are on the Earth, what we're really talking about when we talk about lines of longitude is taking these circles, or dots for the poles, and then saying, where am I on this circle? How do I calculate east-west by working out where I am on this circle? And of course the conclusion to it is that a circle is 360 degrees, the rotation is 24 hours, so every hour of time difference between two places is equivalent to 15 degrees of difference of position on that circle. And then all of a sudden everybody had understood exactly how you were going to calculate where you are on an east-west position relative to your known latitude. Latitude's not difficult. If you have a clear horizon and you're in the north, you can put a finger on the pole star and a finger on the horizon, and then the angular difference between your two arms is, broadly speaking, your latitude. But longitude, much more complicated. How are you going to work it when you're constantly rotating and when you don't know where your position is? So this was critical. One way of explaining it to people is to say, look, north and south are real places. They're destinations, you can go to them. Think of all those explorers. They arrive at the North Pole. You go to the South Pole, you arrive at the South Pole. There's no East Pole or West Pole, and you can't go to a destination east or west. You can only go in an easterly or a westerly direction. So fundamentally, very different things. And what's the solution to it? Well, of course, it was to look at the sky, and it was to work out in the clock of the heavens what that time difference was between a known place and the place where you currently were. Now, the place where you currently are, you can easily do by watching the sun, and when it's at its zenith, you know it's midday. So at the highest point of the sun, that's midday. But then you work out the lunar distance to a known place, your home port, and you do a series of calculations. You're basically shooting the position of known constellations, and you shoot them against the moon, and you make a very complex calculation. So this system works. This system is still used, and it's fundamental. And it's not entirely competitive with a time differential using clocks, because the two of them are interlinked. But this is hard work. This is what the observers were going to enable, and they were going to enable it. Sorry. They were going to enable it. Come on, let's go back. You can do it for me.
I think that remote's dead. Just use the keyboard.
Oh yeah, sorry.
There we go. Sorry.
That's the. So the first thing to do was that what you wouldn't do, you needed to have a complete map of the heavens. Then you could make your references to the star and to the moon, and you could find out exactly where you were. So the first job, this is an image of the Optican Room in Flamsteed House, which is the observatory I showed you on top of the hill, and you'll get better pictures of it later. And they're starting a mapping of the sky. 1675, under instruction from Charles II. It's built and operational in 1676, and this is what it looks like. This room was designed specifically to be the first scientific building in Britain. And you'll see them observing the stars now because they're going to map the heavens. The building wasn't entirely perfect because they'd used the foundations of a pre-existing castle. So very quickly Flamsteed decided that it wasn't properly aligned. So like most astronomers, he went out and worked from the roof or from his garden shed, which he built next door to it. I think men are generally much happier in an outbuilding than they are in a house. So this is a really beautiful room, and it's still very much in the style at Greenwich that you see here. And you'll see the portraits here are of Charles, as we showed him earlier, but also of James, his brother, who took over after him. They start work. And the work goes on, and the work goes on, and the almanac or the celestial map doesn't appear. There are two people on the picture up here. First of all is Sir Isaac Newton, probably most famously known to people as the kind of inventor of calculus and explainer of gravity, and then Flamsteed himself. And Flamsteed was a classic data man, compulsive type, completion of the project critical to him, detail. He did an enormous amount of work that would stay valid for many hundreds of years after his death because of his exactness, the preciseness of the work that he did and the long hours that he worked in difficult conditions. Newton was a great thinker, and his understanding of science wasn't complete data, it was imagination, theory, and enough data to test. And once you got enough data to test, then you could start work. And Newton wasn't very empathetic. So he told Flamsteed that he was a plodder. The trouble with you is you're not really very clever. Just give me your data and I will organise it for you and test the things that we need to test and get things moving. Needless to say, this went down very badly. But it's really important because the frustration is growing. It's 1675 they start this project, and the pressure on it is that there's a huge amount of transatlantic trade to be done. And people are getting lost, they're missing their destinations, they're also having accidents. And Newton's desperate for the data, and Flamsteed is very retentive. So Newton, with Halley, steal the data, and they publish it. Flamsteed leans on his royal patron, and he starts a process of buying back the books and then burning them. And I just love this story because to me it just strikes me of that kind of position we're in today, where our data's being scraped and without our will we're losing all this information that's being stripped from us. And it feels a bit like this struggle between these two gents. But it also makes us think about what's the nature of science. Because much, much later, of course, with Einstein, you'll come across a scientist who always prized imagination as the most significant thing a scientist could have. The maths can come later, but you have to have the big ideas. But this is a big problem. 1712 this happens. So by 1715, the Admiralty and the Board of Trade are absolutely furious that they haven't got the data they need and they haven't got the competitive advantage that they should have got from having installed the observatory. So they invented the idea of the prize for longitude. Whoever could come with an idea that would solve the exact measurement of longitude would get £2,000. Sorry, £20,000, which was a huge amount of money in those days. Now, they thought this would be a huge stimulus to get Flamsteed and his fellows to work a bit harder, print a bit faster, and get the almanac out. Instead of which, they got this guy. So John Harrison turned up, a carpenter from Lincolnshire, and he came with a very different solution. He had designed a clock, and his great carpentry meant that he was technically very good, and he realised that if you could get a clock that was accurate enough, then you could set it in Greenwich at the start of your voyage, and you would have a second clock that you could simply use by shooting the position every day and setting every day, and then you'd always know the time difference between Greenwich and where your ship was. And this would give you your longitude solution. Now, this isn't very different from the lunar tables method. It just takes out very complicated calculations and gives you something quite robust instead. The reason clocks were difficult is that accurate clocks that could keep time over long periods and sea voyages very easily 5 or 6 months. So how are you going to have a long distance sea voyage and keep your clock accurate? Good accurate clocks have long pendulums. Long pendulums don't operate well in dynamic environments. You can't shake a grandfather clock and it keep time. So we had to find a different way of doing it. And he came up with a series of stunningly clever ideas. So these are the 4 clocks which we have at Greenwich and which are real heroes of our observatory. And this one here, what you'll see is that he has 2 balance bars and then a spring centre here, and these replace the pendulum. He had major parts in wood, cogs in wood, internally to the machine, to the clock. And on the most movable bearing parts, he used lignum vitae, which is a type of wood which self-oils. If you've ever heard of crying Madonnas in churches, it's lignum vitae, because the wood naturally oozes oil, which will appear and then retract. It's used on ships as bearing bushes to carry the main propeller tube, because they're not used these days anymore because we use other materials, but they were used. Certainly I've bought and sold ships that had lignum vitae bush bearings, because the wood will hold the propeller shaft, and as it turns, oil is produced under the pressure, which lifts the load on the bearing, and then when you stop using it, it oozes back in and it doesn't leave a sticky deposit. And he used them in this clock. And he took the clock on a sea voyage to Lisbon, and it performed better on the way back than on the way out, and he performed very badly in both directions as he was heavily seasick. He then produced a second because he realized he had to improve things, and in the second, which is equally beautiful in its motion and appearance, he also put some dressing on it and dedicated it to George II in the hope that he might get a bit of attention. Now, the first clock got him some pin money from the Admiralty Board to encourage him to carry on with his work, to pay for some of the expense of what he was doing. And he went on and designed a third, which took 20 years. And you'll see the big change here is that he started now not to use these balance bars and springs, but to use a huge rotating flywheel that would exactly balance the timing of the release and of the movement of the powering springs, of the powering coil spring. So he was working really hard on these. Each time he kept bringing them, the Admiralty had a major problem. These were going to be extremely expensive to make. This is about 2 foot tall, a little bit over that. They're heavy. They've got a lot of parts. A lot of them are very delicate, even if they are better than a pendulum. But this does not look like a replicatable, affordable system that could go on board every ship. And you would need at least 1 and possibly 2. So you can imagine they looked at it and thought, well, he's kind of solved the puzzle, but he hasn't cured the problem. They gave him more seed money, but they wouldn't give him the full prize. After 20 years of work on these, he scratched his head and thought, I'm barking up the wrong tree. And then he had this enormous moral courage, and he jumped to this, which is essentially like a pocket watch, a bigger version. And for this, he eventually received the full prize money, because this, they could see, was a workable solution. And to them, more workable than you might have otherwise thought, because they also were a bit worried about the lunar distance tables, because you had to be able to make accurate observations at sea, which is often very difficult. Also, you then had to do extremely difficult calculations in mathematics, which I suspect they wondered were really within the abilities of a sea captain or an admiral. They were the sons of the rich, not necessarily the brainiest in the class. So maybe that was another problem. And it's again, another interesting modern problem. People preferred the solution you could own to the solution that was dependent on rationality and calculation. His solution was beautiful. Maskelyne said that it wasn't as good as it needed to be, and Maskelyne was the Astronomer Royal at the time, and I think there was one reason only. He didn't like the fact that this was meant to be solved by astronomers, and it had been solved by a clockmaker from Lincolnshire. So there was a little bit of that grudging, what's going to happen to us? Well, what happened to the observatory is that it became the centre for testing time. Time would be set by looking at the heavens, the difficult maths and the calculation, we would give them we would have Greenwich Mean Time from the observatory, and then at the door of the observatory it could be sold to people and they could take it off into the city, and with it they could go around selling to other people accurate Greenwich time. So right away we start to see time as a commodity. But there's this huge powerhouse behind, and we ended up with a massive amount of trade as we start to have globalization. The first example of this was in a unified network of railways in the UK, which meant that we had to have specific national time for Britain. We couldn't have Bristol time and London time. Otherwise you could end up in the situation where you couldn't have an integrated rail network because of the risk of collision, because of the difference of time from the local area. So we moved to a unified time. But by the end of the 19th century, the telegraph's been invented, and we have global trade with banking transactions, so that a ship that arrives in Hong Kong might well want to have money sent to it, or money sent to it by a private message sent to a local bank in Hong Kong to release funds to the captain to buy cargo. And this would happen and had to be time-stamped. So we moved to international finance of trade, and at that point we need a unified global system. If we have a unified global system of time, then we need to make sure that we also, what goes with it is a prime meridian, a single place from which we start the day, and then a unified time sequence. And so thank you USA, because there was a big conference in Washington, and at the conference in Washington there was a big argument about exactly whose meridian we were going to use, because of course it was completely natural to the French that it would be Paris. It was completely natural to the British that it would be Greenwich, and no doubt it was completely natural to the Portuguese that it would be Lisbon. But the solution was come to by the American delegates, who simply said, look, 75% of world trade is being done with ships that carry the Admiralty charts. So that all of those charts on all of those ships essentially have the prime meridian. So we're going to go with the prime meridian at Greenwich, because we're not going to start making adjustments on all those maps and all those charts just to meet a vanity of a shift for the French prime meridian or for another prime meridian. So eventually it was settled like that, and this was the agreed prime meridian. There's no reason why it has to be Greenwich, but the reason we got there is because we'd actually distributed the solution ahead of the discussion. Not deliberately, we just got a competitive advantage. And those of you that I think the audience is, I was worried the audience would be too young to get this reference, but it's a bit like when we had videotapes. There was the great war between Betamax and VHS. Yeah. But the one that won was VHS. Why? Because they were distributed more. People had more access to them. May not have been better. Time continues to be distributed and sold in different ways. At Greenwich, if you come, what you can see is this, which is the time ball. This would have communicated the time to everybody who was in visual contact with the observatory. But that's quite important, because a lot of ships were waiting in the river to go into the port or would pass it. And so every day at 1 o'clock, and we still do this, this is cranked up and it's dropped. And when it's dropped, that means it's exactly 1 o'clock, and you can set your Greenwich clock. It's not 12, because you have to shoot the zenith at 12 for your local time. So that's why it's 1 o'clock. But we moved on. Telegraphy brings us time distributed in different ways, and ultimately we end up with radio, and in the early 1920s we end up with the pips, the voice clock, and you can entertain your grandchildren by telling them, or your children by telling them, there was a time when we used to phone up a number with the telephone and ask what the time was, and we'd get told. And this is the guy who used to do the time. So this was the person who used to read the time, and next to him is one of the first atomic clocks, which we have at Greenwich. The latest version of the atomic clock is accurate to 1 second in 157 billion years. You might say there's no need to do that, but the National Physical Laboratory tell us it's now so critical that you have synchronized time that your phone and your computer systems need to have it this fine in order to be able to work efficiently. So can you imagine losing 1 second in a time series that if you imagined 157 million years, there probably won't be an Earth by then. But nevertheless, there'll be a clock ticking accurately for us all to listen to. At least our funerals will be on time. Right. Now, Astronomy Uninterrupted is I've shown a photograph here, a picture here of the Herschels, because I've talked about time for a while now and not about astronomy. But astronomy did not die as a result of the use of the clock for longitude. Actually, it flourished, and flourished more greatly than you could ever imagine. The reason that they're so important is that these are amateur astronomers, and as I suppose in some extent most people were, and I hope most people still are today. William Herschel was professionally, he earned his living from playing the oboe. His sister was a good singer as well, but he'd come here following his father to get out of military service in the Hanoverian army, and he'd played music around in the bandsman's corps, but he was obsessed with astronomy. And what you can see them doing here is polishing a reflecting mirror. So Newton had designed the idea of a reflecting mirror, but it was Herschel who perfected it by making it much, much bigger than anybody had imagined before. But this is a joint enterprise. His sister is not doing something motherly or sisterly to him. This is two scientists working together, because his fingertip imprint on the mirror is telling him where the sticky parts are and where the shiny parts are. If he takes his hands off it, he will lose the mental shape of the mirror he's polishing. So they work in a monumental session of polishing, and his sister has to feed him while he's doing it. But this is a collaborative, joint scientific enterprise. This is not a domestic scene of somebody who's too lazy to chew for themselves. When that, we have part of a casing from the refractor that was eventually made, but 20 foot was the size of the telescope. He even made one that was 40. But when it worked, he was able to identify 2,500 objects that had never been seen before. It was mind-blowing. It was a great leap forward. On his first night of observation, he saw a new moon for Saturn, and the next night another. So immediately it was like a warp factor change, and the full depth of the celestial heavens had begun to open up. And then it's really astronomy moving to astrophysics, getting depth into the field of vision. He also noted that under a red lens, he could feel his hands warm. And he had spotted infrared heating. So there was this really fundamental step changes, and this is in the mid-18th century. So we're on the way. And the race starts and it continues. At Greenwich, we ended up building the largest refracting telescope that there's ever been in the UK, and the 10th largest that was ever built in the world. So this is a 28-inch refracting telescope, and there are really no prizes for guessing why we had to build one that was that size. It was because the French had one that was slightly smaller. I wonder what we would do without each other, actually. And what's funny about this is that this was quite a miserable job anyway. You see he's enjoying himself and he's got quite a comfortable view, but his understrapper has to sit on the floor down here taking the numbers down, and of course freezing cold at night, and all observing is done at night. There'd always been one of the problems is the comfort, but they used to be able to have a very special chair that you could roll around underneath and you could look through through the telescope. This was no longer possible because they put that telescope on this old mount, and it brought the end of the telescope so low that they had to lie down to use it, or use this standing edition here. But this is still there. We have evenings when you can come and see stars, evenings with the stars, where you can come in and use this telescope. It is fantastic for looking at, well, it's fantastic for looking at lots of things, but we can enjoy it a lot looking at the moon, looking at Jupiter, looking at what we, our near neighbours. And we have some wonderful imagery, and it has a lovely old-fashioned watery look because there's so much atmospheric disturbance. But it's a really beautiful instrument. This could be moved and positioned by a child. A child of 5 or 6 could move this because it's so delicately balanced. And also there is a huge pit in front of it, and it's called the equatorial because it will track the movement of a star whilst you're looking at it. But the big pit in the front of it is in fact a huge funnel with a sieve at the bottom, and they would load this with packed ice. And then as the ice melted, it would dribble out at a known rate, and this would act as the motor to move the telescope. It's a really wonderful thing. It's one of the jewels in the crown that we're going to show off brilliantly when we renovate in a little while. Greenwich and the end of observation was just industrialisation of London, the expanse of the city. You can see already how smoggy it is, but you can also see there's a power station. The power station provided electricity, and electricity disturbed the work that was being done on magnetism. And of course, Greenwich did a lot of work on weather, on magnetism and on gravity, all three of which, even from the days of Flamsteed, had started to be observed in the data they were collecting when looking at stars. They could see what the impact of weather was, of course, because it was always in their way. But they could also feel gravity, and they could note and feel it and document it, and the same with magnetism. So these have been important areas where astronomers had branched out, but of course these came to an end when there was so much local interference from the city. And that's 1950 and something when we had the last great pea super in London, and as a result of which we banned burning of coal fires in the city. But moving to a new era, this was 2007. And in 2007, we had, this is the dome of our planetarium. And behind it, you can see the 1890s Christie building, which itself housed a telescope in the roof. You can see the slit for it here. And this has subsequently become our teaching building for astronomy and astrophysics. And in 2007, we added the planetarium, which enabled us to be able to use a planetarium which is not a film, it is a database, and the person who runs the database is an astronomer. So when you come to a lecture with us in the planetarium, we might show you the sky tonight. But if at the end of in the Q&A session you say, can you explain to me how a nebula creates a star, the astronomer can take you to a nebula in space, show you it, because the database is there to take you directly to that. If you say, I want to look back at the Earth from Mars, they can take you to Mars and look back at the Earth. I once went with a friend who was visiting me from Australia, so the astronomer said, well, before the rest of the crowd comes in, why don't we go to Sydney and see the night sky tonight? So just flipped the database around and we looked at the night sky in Sydney, and he ran through the constellations. So it's a really wonderful thing, but what's great about it is that you get to meet a scientist. You can ask them a question. If we have a class of Key Stage 1 or 2, which is 7 to 10, the question is normally, are there any poos in space, or are there aliens, or something like this. But you can ask them any question. They can always tell you, I don't know. Or they can say the latest theory is this, or we're thinking about it this way. But it's a really good contact. It's critical because it's dialogue. And dialogue makes all the difference. This is one of our astronomers with the planetarium image behind doing just what I've been talking about. Critical elements that we've learnt through this teaching process are going to be taken into the way that we renovate and think about the observatory going forward. It's critical to us that human beings are shaped, their minds are shaped by dialogue. There's no substitute for it. Conversation, rationally engaging in a conversation based around the acceptance of fact or the rejection of fact. Dialogue which enables you, once you've accepted what positions are, to start to use a rational mind to come to logical conclusions. It's always said that human beings are separated from the primates by an opposable thumb. They are, but they're also separated by the ability to be rational, and they're also separated by an extremely sophisticated system of dialogue. And it's really important that we talk to each other in a rational, factual, and effective way. You can contest argument with fact, not with opinion, not with prejudice, not with blind faith. You must rationalise, you must dialogue, and this is the whole point of what's been going on for 350 years as people turned their telescopes on the heavens and began to work out what they were looking at. And that's something we really want to instill in it. We want to upgrade a lot of the infrastructure, and we want to show some of the beauty of the things like Harrison's clocks. I've been very lucky. Last week I went into our stores where one of them was being repaired and it was laid out on a workbench. The structure was on one side, but all of the gubbins from the middle had been laid out and catalogued as somebody was working on them. The very privileged conservator was able to see, and possibly only 2 or 3 people have ever seen, all the little annotations and markings that Harrison had put on that clock in the 1730s while he was cutting it and assembling it. A total communion of individual experience, and something that we'd love to be able to share with the public, and I'm sure we will be doing. Also trying to embed it fundamentally in the conversation that we've been having this evening. Here you can see an example of the almanac that was eventually completed, mapping the skies to enable people to do lunar distance method, as well as some of the equipment that's used in order to shoot those positions, and embedding it in a shipping story that explains why it was so important. But to do it in an effective and meaningful way, which makes people curious and experience, touch, smell, sight, all of these things can help to break down some of the anxiety that people feel about subjects which they fear might be complex or above them. I hope this evening when I've been talking to you, you've seen it as a practical social thing, because it's very real. We don't need to be frightened about it. We didn't need to worry about somebody else knowing more than us. That's a great opportunity to learn. And if we can encourage that environment where people are sparked in curiosity whilst having fun and enjoyment, then I think we can leave them curious and eager to learn something and eager to go home talking with the people that they've toured with and thinking about what they might like to read next. And here's an image of a courtyard that we're hoping to build in the middle, which would house some of the thought-provoking thoughts. And we've been also looking at the information that can be gathered so that we could present walls that will show current and up-to-date ideas and the latest developments in astronomy from all the wonderful things which seems to me are all happening around you here. Whether it's at SpaceX or whether it's JPL and Caltech, I mean, what an exciting place to live, so close to so many important things that are happening. Here's our great equatorial with 2 of our very intrepid astronomers using it at night for observing. It's an important part of what we do, and giving people the opportunity to look through a telescope when they come to an observatory and see something. During the daytime, the object that we can all see is, of course, our star. People say you can't see the stars during the daytime. You can't, because one star is predominant. But if you take a telescope that's a heliotelescope, then you can see the most fantastic vision of energy movement on the surface. I was discussing before we came in here the fact that you may think that a lot of this calculation or observation or working out navigational positions is something that's a little bit history now, because anyway, I can pick up my phone and I can use it. Even people on board ships will have satellite positioning systems that will tell them where they are, to within the minutest detail. So why would anybody bother thinking about teaching navigation anymore? And the fleet of ships that of the company that I used to run, every captain had a sextant on board. Every captain, every week, shot his position and compared it to his GPS position. Why? Because what happens if it's not there? What are you going to do then? And you may well say, well, it's not going to happen. Or maybe there'll be some cyber attack that brings them down. Never mind that. In 1859, there was the Carrington event, when there was a massive solar expulsion. It was so large that the northern lights could be seen in the Mediterranean during the daytime. The telegraph in America worked without being connected to batteries. Animals were fried standing close to barbed wire fences. If this happened now, tomorrow, all the satellites that weren't protected in the shadow of the Earth would be destroyed. That means all geopositioning systems would be pretty much finished, at least for a year or two until they were repositioned. Solar weather watchers are watching for this all the time because it might give you an edge where you could move a satellite to protect it. But this is very real. And so knowing and fundamentally understanding would be really, really important to you. Navigation is not history. It's a fact, and it's a good science to know and understand. This is, I don't know, I hope I'm running your time schedule a bit tight, aren't I? I was just I wanted to be a bit anecdotal about this guy, actually, because he's a brilliant astronomer. But I went to see him once with my daughter because we'd seen a Perseid meteor shower. And my daughter had asked me afterwards, and I think this is not uncommon, after we watched this Perseid meteor shower, she said to me, how do the Perseids know to come on the 7th of August? And of course, I didn't have an answer. But instead of making one up, which was my normal, default mode, I said, well, I'll tell you what, when we go back, we'll do a course together at the observatory. So we came back and did a course together, and he taught us. And I said to him at the end of the first lesson, oh, Brendan, how do the Perseids know to come on the 7th of August? And he said, Paddy, he said that, he's Irish. I just want to make sure you got the accent. No. He said, Paddy, it flies on a windscreen. I said, no, you're going to have to work a bit harder than that, Brendan. What do you mean? And he said, it flies on a windscreen. So that was my first engagement in understanding that the Perseids, he just said to me, look, the 7th of August, as you call it, is a place in space. And that place in space we go through every year on the date you call the 7th of August. In that place is a curtain of dust left by a comet. And every 7th of August, the Earth goes through it at 100,000 kilometers an hour. It's 100 times faster than any aeroplane I've ever been on. And all those particles smash through the atmosphere. And as they smash through the atmosphere, they burst into flame. And you never need to use binoculars or telescope. They don't help. They make it worse to look at shooting stars. Why? Because they're in the atmosphere. So that was a real moment for me. I never really thought about the orbit of the Earth being a year. I'm not a natural astronomer. I'd never really, I knew it all, but it had never been concretely brought to me. This is like a moment where Brendan is not just doing research, he's doing invention in my mind. Right? This is a scientific moment of discovery. Now, it may well be that that was known by somebody else 2,000 years ago. But for me, this is the moment of discovery. And that's what powerful places like Griffith's and the observatory in Greenwich do. They create moments of discovery in the minds of their visitors. Every bit as important and as powerful, because it's no good being a scientist on your own, unable to explain to anybody or to share with anybody what you found out if the people you're talking to can't understand what you're talking about. You have to create a herd of people who understand what you're talking about. And that's what's so important for us, to make sure that our society is elevated enough in its thinking to be able to engage in the discussion, which enables us to move forward and have a platform for further discovery. There's so much to do. Brendan here is standing next to a telescope that we use for research on site. And having not researched or done any investigation of the skies in a material way for 50 years, the observatory is now using this telescope to do research with universities in London and having distinct success. Recently, we tracked and discovered an exoplanet as it transited a distant star. So we're really excited by it. We're also able to take images like these, the Andromeda Galaxy, and then a couple of other distant nebulae and clusters. We're going to move forward to make sure that we plant out, as well as capturing some additional areas to teach in, we will also plant out the observatory, because landscaping and gardening are essentially a form of astronomy. I think there would be no better way to start a small child of 3 or 4 on astronomy than to get them to help you plant a nasturtium seed and to think about all light is starlight and light is life. So everybody is an astronomer. Any gardener understands the obliquity of the ecliptic that creates the seasons of Earth. Everybody should know that it's because the Earth's tilted. So these are the sorts of things that we can make it real in a way, because it is real. These are the reasons. This is what it means to you. So embedding those early on so that people will always carry them with them. This would be a great thing for the observatory and a great thing for all of us. This is the Earthrise moment. I'm sure you're all familiar with it. But when Apollo 8 went to the dark side of the moon, William Anders saw this, and his comment was, "We went to the moon and discovered the Earth." And then we have it, the blue planet. So when we're looking in distant solar systems, or we're looking at distant stars to say, are there aliens, we'll look in the habitable zone. And the habitable zone in our solar system would be Venus, Earth and Mars. That area which is, we think, not too hot to make life viable and not too cold so that life could be viable. And those 3 planets should be in the habitable zone in our solar system, but Venus for sulfur atmosphere is too hot, and Mars without a magnetosphere doesn't have an atmosphere, is too cold. But Earth is not only in the habitable zone, it's the Goldilocks planet. And it's covered with water, so heat is distributed to make even more of the planet habitable. When we go to space and we see all these different planets in different galaxies and we see all these different stars, we have to think about how fortunate we are that we have been Earth human beings. This is our planet. We can go to the moon. We can go physically to Mars. I'm sure we will do. But not to escape Earth, because we're Earth beings. This is us. This is home. What we have to learn is how we're going to live here together, rationally, thoughtfully, empathetically, using language and dialogue, using our rational gifts, and use our incredible ingenuity and our craftsmanship. That's the real secret, and that's the real prize that astronomy can bring. As the founder of the Griffith said, if everybody could look through this telescope, we would change the world. Thank you.
Thank you so much. Thank you so much, Paddy. Can we have another round of applause for our marvelous guest speaker? Thank you so much. Thank you. Thank you for joining us this evening. This concludes our lecture. We invite you to explore Griffith Observatory. We have a planetarium show at 8:45. We are open till 10 p.m. It is Friday night, and you could not be in a more beautiful place to take all of those inspiring words into your weekend. And enjoy your visit. Thank you.
Very nice.